Welcome to the Regular Expressions aka Regex Masterclass. In this video, we're going to be covering all things regex. We're going to touch on Python, JavaScript, all the intricacies of regular expressions, definitions. You know, over the last 10 years of my career, I have become fluent with regex, and I've noticed that it is this super powerful tool in my arsenal. What is regex? Regex is a way to perform powerful pattern matching and search and replace on strings of text, and it really can be used in a wide range of different scenarios. So in this video, we're not only going to lay out how regular expressions work and the definitions and how to build them, but we're going to show you tons of real-life examples like password validation or web scraping. So you're really going to understand how this works in action. This is one of those videos that if you put some upfront investment and watch the entire video, this is going to save you tons of time in the future because it's going to accelerate your ability to develop at a faster pace. Anyways, let's get started. Okay, so we're going to start off using a publicly available Regex Validator. And towards the end of this video, we're going to actually use Python and JavaScript to show real-world implementations of regex. But just to get you acquainted with the terminology and all the different syntax and patterns, we're going to use one of these validators here. Now keep in mind that every major runtime has a regex engine, and they're all very similar. I would say there's subtle different flavors between them, but I would say they utilize 95% of the same exact syntax. So if you learn regex in one language, you're really learning it in all the languages. So the first thing is a regular expression is denoted by 2 forward slashes, and you put your pattern between them. To the right of the second forward slash is the modifiers or flags, which will introduce global rules to the entire regex. For instance, I is a flag that says make the entire regex case insensitive, and we'll go over the remaining flags later in the video. So one thing I want you to keep in mind is that a string is also a regex. It's just an exact search regex. So if I type HTML into the regular expression, it will match on all instances of HTML and it will be case sensitive. So when we do this, we're using literal characters. When I type in H, I'm literally looking for another H. These are called object literals. In addition to the literal characters, there's a special set of meta characters called special characters, which have a specific meaning. And when you type them into a regular expression, you don't actually look for those characters, you're looking for something more generic. So we're going to start by looking at the various meta characters. So the first and most powerful meta character is the dot. The dot will match on a single instance of any character. So it is the most broad, generic, regular expression that you're going to have at your disposal. So if I go ahead and type in a dot here, you will see it matching on every character. So the next meta character is the question mark. The question mark says, for any pattern that is followed by a question mark, make the pattern optional. And this is useful if we want to match on a pattern that might contain a character or a substring and we're not sure. So for instance, in this example, say we want to match on both open and closing HTML tags. Well, closing HTML tags have a forward slash in them and the open do not. So we can utilize the optional character in order to match on both. And so this would look like the following. And now we have a regex that is generic enough to match on both open and closing HTML tags. Next we have the pipe, and the pipe just says or. So say we wanted to match on 2 terms, we could just put the first term to the left of the pipe and the second term to the right of the pipe, and now we'd match on both instances of the string. Now you can see that we're matching on instances of H1 and instances of HTML as well. And we can continue to expand that sequence as long as we'd like. If you're liking this video, go ahead and turn that like button blue so we can get it out to a wider audience. Thank you. So now I want to talk about regex shorthands. Shorthands are little sequence regular expressions that tackle common use cases, for instance, matching on a word or a digit or a space. So let me go ahead and show you those. So the first one is to match on a letter is \W. So now you can see we're matching on all the letters in the test string. To match on a digit is \D. So now we've found all the digits in the string. And then to match on a space, we use \S. So So let's talk about anchors for a second, because I find that these are pretty much necessary for writing comprehensive regular expressions. So an anchor is, for any given test string, you have lines usually, so new lines, but you also have a start of the whole blob of text, right? The very first character, and then you have an end of the entire blob of text. So how do we denote these different orientations within the test string? And the answer is we use anchors. So the start of a line is going to be denoted by a caret. And that looks like this. The end of a line is denoted by a $sign. And that looks like this. The start of the entire blob of text is denoted by \A. See, that only matches once on the very start of the test string. Likewise, if we want to match on the very end of the test string, we use \Z. This is useful because it allows us to place the regex in a certain position, especially when the test string is very long. Take, like, for example, an entire HTML document. We might want to find the first or nth instance of something, and in order to do that, we need to know where we are and be anchored to the start or the end of the string. Okay, now I want to introduce a concept called repetition. So say, for instance, I wanted to match on 2 digits. I could do that with \D, \D, but there's a more concise way to set that up. I could do 1 \D, and then I can define the number of digits that I expect to show up. And to do this, we use curly braces to indicate the number of times we want the preceding regex to appear. So I'm going to do open curly brace 2, close curly brace. And now you can see it only matches on the 16 because that's the only instance in this test string where there are 2 digits in sequential order. Now this repetition syntax can get even more comprehensive. We could create a range. So we could say find digits that fall between a min and a max. For the sake of this example here, let's find instances of digits that have at least 3 to 5 characters. So I'm going to use 3 for the min and 5 for the max. And now you can see we're matching on 1, 2, 3. We're also matching on 1, 2, 3, 4, 5. So again, these repetition functions allow us to just create more concise regular expressions. If we wanted to match on 5 digits, we could do the following. Or we can just do this. And as you can see, this just shortens the regular expression. It's more efficient. A couple other little notes here is if we don't want a min or we don't want a max, you can just leave it blank. So say we wanted to do find digits that have 3 or more characters, I'll just do 3, blank. And now you can see we're matching on all instances where there are 3 or more characters. Now, instead of using the curly braces, there are a couple shortcuts that have been made just for convenience. And the first one is the star, the asterisk. So the asterisk says that look for 0 or more instances of whatever the preceding regular expression is. So if I do \D star, it looks for any number of digits. The next one is the plus sign. The plus sign says look for 1 or more. And now you can see we're matching on all instances where there are 1 or more digits. The asterisk and the plus sign will usually be interchangeable, but for a small set of narrow use cases. And the more generic one is the asterisk, so I'd stick to using the asterisk and you'll probably be good most of the time. There's just a couple scenarios where it matters if you use the asterisk or the plus sign. Okay, let's talk about capture groups. So capture groups are denoted by parentheses, and they do 2 things. One is they allow us to create a sub-regex, which is very powerful. 2, they allow us to store whatever is captured in that sub-regex in memory so that we can reference it later, maybe for search and replace or maybe for back references. So let's create a little capture group. And you can see I use the pipe to denote those 2 strings. Okay, so to give you a real feel for how capture groups work, I'm going to write a regex here that matches on the h1 tag, and we're going to extract the inner text of the h1 tag. So you can see this regular expression is using the open h1 tag and the closed h1 tag to kind of anchor the dot star question mark, which will eat up everything between those two anchors. And then we use a capture group because we want to store that text in memory so that we can reference it as a capture group. So I'll show you how to do that. So if I pull out the match information here, you can see the first part is the match, which is the entire regex, but the second part is what the capture group referenced. And in code, if we wanted to reference this capture group, we would do so by using $index. And in this case, it's the only capture group, so it'd be $1. But as you build more capture groups, and you might have nested capture groups, you need to know that they are referenced based on their sequence within the regular expression, and specifically the sequence of the open parentheses, because it's going to get very complicated as you have nested regular expressions. But all you need to keep track of is the open parentheses, and that will give you the index of the capture group so that you can reference it later. Say for instance, if you're doing a replace or a text extraction function. So say I also wanted to extract the text from the paragraph tag, we can modify this regular expression to be generic enough to match on both instances. So I'm going to go ahead and do that. Okay, so you can see I introduced a couple more capture groups and the pipe, in order to make this regex more generic. But say for instance, I don't want to use the first and last capture group to store anything in memory. I just want to use them for the ability to create a sub-expression. We can actually cast it to a non-capture group by using a $: in the beginning of the regex. So you can see on the right all the different groupings that it captured. But again, we don't want to capture the tag name. We just want to capture the inner text. So we're going to use that $: to convert the first and last capture group to non-capture groups. Okay, and now you can see that we're only storing that capture group that we care about in memory, and the other ones are just used for the sub-expression function. Now, I don't think every regex engine supports this, but some of them do, and what you can do is, instead of using $1, you can actually name the capture group. So say, for instance, we wanted to name our capture group inner text. We could just add a $, and between two left and right arrows, we can add the name. And now you can see the group is referenced by its name, not by its index. Okay, now let's talk about character classes. So character classes are denoted by brackets, and anything that falls within the bracket, it will attempt to match on. So it's kind of a way for us to create a very generic expression. So say for instance, I wanted to match on any letter or digit, we could do that by using the following. And again, this only matches on single instances, but say we wanted to do any number of letters or digits, we can add the repetition flag plus to say match on n number of characters or digits. And then if we add the plus, it will match on any number of characters or digits, and you can see how that changes what is actually matched on. Now I told you that the \D and the \W were actually shorthand, and that is true. There's actually a different way to match on digits and characters that is sometimes useful. So if we want to match on any number of digits, you can use the range function to determine which digit you want to match on. So say we wanted to match on 0 through 9, you could do 0-9, and that indicates it'll match on that entire range of digits. And intuitively, if we wanted to match on only 1 through 5, we could just create a range that indicates that. Likewise, for letters, you can use a range for the alphabet. So we could, if we want to match on any letter, we could do A through Z. And this will be lowercase letters. If we wanted to match on uppercase as well, we would just do capital A through capital Z. But you can also put any character in here. So say we want to match on /, we could throw those literals in here as well. We could also do spaces. We could also do something interesting, which is called a negated character class, which means it will match on anything except. So say we wanted to match on anything except a white space. So to create the negated character class, we just start with a caret followed by the character that we're not trying to match on. So now you can see we're matching on everything except for spaces. The reason negated character class are useful is because they will allow you to look for everything except the next instance of something. So in a way, it functions very similar to $?? So let's actually redo the regular expression to find the inner text, but instead of using $?, let's use the negated character class. So once again, we're matching on everything between the right arrow and left arrow, but we didn't need to use the $* in this case. So with the $* or the $+, there's two concepts I want you to keep in mind. One is lazy versus greedy. And lazy just says find the next instance, and greedy says find the last instance. So say we wanted to capture all the text leading up to the first anchor tag, we would use the lazy approach. So I'll go ahead and create that regular expression. So you can see because I use the question mark, we're capturing all the text up to the first instance of the anchor tag. But say I wanted to get all the text up to the second instance of the anchor tag, I would just have to remove the question mark to make it greedy, and then we would actually include that additional text. And now you can see we're going up to the last instance of the anchor tag. So just keep that in mind when you're writing your regular expressions. Okay, and then one thing I quickly want to gloss over, I don't think it'll be used very much, but there's a concept called back reference. So say we create a sub expression with a capture group that looks for ABC. So it's looking for, actually, sorry, let's make it more generic. Let's just look for 3 letters. And 3 letters followed by a hyphen, just to make it more specific. So say we're looking for 3 letters followed by a hyphen, but then we want to check later on if that same exact expression, whatever matched, so in this case it's ABC hyphen, say we want to check for ABC hyphen later in the later in the string, but we don't know it's ABC hyphen, we only have this pattern here. Well, you can do that by referencing the capture group as a back reference, and the way you do that is you do \index. So say we want to then check if that shows up elsewhere in the string, and actually let's just throw it in the string so that it does in fact match. We can do that. So we're going to do $*, and then we're going to look for the back reference. See, we're saying look for 3 letters followed by a hyphen, anything in between leading to the same exact pattern. And we do, and that criteria does fit this here. Because we have ABC hyphen, ABC hyphen. And as you have more capture groups, you would just change the index on the back reference. Okay, and then I just want to show you how to use the capture groups. The other tool doesn't really display that very well. But let's just modify this. Let's say we want just the first 3 words. So we'll anchor it to the start. Okay, and actually we want the next word. And we'll get rid of this complex guy here. We'll just do \W+. All right, and then we're capturing each of the words in a capture group. And then say I want to rearrange them, I want to reverse them. $3, that's the third word, right? $2, that's the second word. And then $1. And so we can put it in any order that we want. So again, word 1, 2, 3, regexer was created, and then we're reversing it, created was regexer. So that's how you use actual capture groups. It's usually in the context of search and replace. Okay, next is probably the most advanced concept, which is positive look-aheads and negative lookarounds. So a positive look-ahead says find a regular expression that is immediately followed by some other expression, but only include the initial regular expression in the matching. So say for instance we wanted to match on any letter that is followed by a white space, but we only wanted the letter to be part of the regular expression itself. We can do that using a positive look-ahead. So the positive look ahead is denoted by a capture group with a question mark and an equal sign. And you can see that this pattern is matching on letters that are followed by a space. So that's the qualification, but it only matches on the letter itself, not the space. Next is negative lookarounds. If you want to create a regular expression that says match on text that does not contain some subtext, that's where you want to use negative lookarounds. So the negative lookaround is denoted by the question mark and then the exclamation point. And what we're saying here is look for right arrows that are not immediately followed by blank white space. So as a result, we only capture those right arrows that are immediately followed by another character and not a white space. Now, if we wanted to say does not contain, I'm going to show you that regex. I know it's going to be kind of intimidating, but I will show you how to do that. So say we wanted to match on any line that does not contain the phrase HTML, we can use a negative lookaround to accomplish that. So we'll start by using the start of line and end of line anchor, and then we'll use question mark to match on anything, and then we'll use the negative lookaround to say but does not contain HTML. Okay, so now you can see we're matching on every line that does not contain the word HTML. And this is really, really useful. And again, we can expand this out by creating a subcapture group. And what we could do is we could say any line that does not contain HTML or body. And now you can see we're only matching on lines that don't contain HTML or body. This is a really useful one to have. It might be something you have to copy and paste, but it's good to be aware of this one. So the final thing we did not talk about yet are the flags or the modifiers. So the biggest one I think is just G for global and I for case insensitive. Say we wanted to match on any letter and we wanted to do that using A through Z in a character class. This matches on the first instance. But if we add a flag to make it global, now we're matching on every instance. So I basically always want global. If we wanted our regex to be case insensitive, we can just go ahead and add the I flag to it, and now it's case insensitive. And so I think there are a number of different flags, but really those are the most important for most use cases. Okay, so let's do like a real world example here. So say we wanted to construct a pattern that matches on email addresses. How would we go ahead and do that? Well, we can use some of the key concepts that we just came up with. So the first thing is every email address has to have an ampersand in it, right? So we can start with that. And then it's followed by a domain name. A domain name, a period, and then a top level domain. So for the domain name, a domain name can have any letter or number in it. So we could do something like that. But I guess what if the domain name had a hyphen in it? Then we'd no longer be matching. So why don't we just do it super generically and do question mark, and then we'll do a literal period. So now we're matching on anything that's followed by a period because we know that's a requirement. And now we just have to match on the top level domain. So I believe top level domains are fairly rigid in that they are always characters. But they could be different numbers of characters. So why don't we just do \W+ for that? And I think that will suffice most of the time. Okay, so now we just need the actual email handle itself. So why don't we go ahead and just we want to be able to match on hyphens, special characters. So we could do something like start, and then we could just do question mark, and then we'll just look for the ampersand. And so now when we are validating a string, we can determine if it's a email address or not. Now this is not perfect. This is what I just came up with very quickly, but this is something that you might actually write with real code when you're building an application. So now that we've done a bunch of examples of constructing regexes, let's actually dive into some real-world use cases and get our hands dirty with some actual code. And we're going to see how this is actually implemented with actual code examples. So I'm going to go ahead and just search for websites, and I'm going to click on one of these ads here. And the reason I'm going to do that is because when I do, there's going to be these URL parameters that are passed in the URL that denote various marketing campaigns. And what I want to do, I'm going to pop open the JavaScript console here, and now we can write some code to maybe extract these URL parameters here. When we're writing a regex with JavaScript, there's two ways to do it. One is you can use a regex object. The second is to use a literal string as a regular expression. So let's create our regex real quick. And now there are different functions that we can evaluate against the regular expression. So one thing we want to first do is just grab the URL. So I'm going to do var URL equals window.location.href. And just so we can ensure that we have that, we're going to go ahead and log it to the console. And we can see there that we do in fact have the URL, including the query parameters. So now let's combine these two and run a regular expression against the URL. And match will return an array of all the different instances where that regular expression was found. So let's go ahead and use that. So again, I'm just going to do window.location.href, and then I'm going to do .match, and we're going to pass in our regular expression. So again, we could just do \w+, and now we are getting an array of every single instance of essentially kind of like a word phrasing. So, and then if we wanted to grab a particular one, so say for instance we only wanted the protocol, we could just index it as 0, and we're only grabbing the protocol there. Now we can also create different regular expressions, like maybe we want to grab all the digits, and we can do that as well, and it's super easy. But say we want to grab the parameter UTM_medium, and we just want the value, because URL parameters follow a name value key pair. So we just want the value. So what we're going to do is we're going to say look for UTM_medium followed by an equal sign. And then there's different ways to get the next word. We could do \w+. So this is now capturing the entire regex, but we only want this substring here. So that's where capture groups come in. So we're just going to throw a capture group around this. And actually for the capture groups to work, we just have to remove the global, which is fine. And now the returned match is going to be the first index in the capture group. So if we don't, we're still getting an array. We're getting a match of the regular expression, and then we're getting the capture group. So with this single line of code, we're able to extract all the UTM_medium campaign values. So you can see that's pretty powerful. Now here's one other thing that's good to have in your repertoire. A lot of the times when folks are writing code and they want to determine if a string contains a substring, they use index of. So for example, they might do something like window.location.href.index of, and then they pass the substring. So maybe they want to check if UTM medium is in there, and if it's not in there, it will return -1. So like if we change the phrase to UTM not found, it returns -1. And then in their if logic, they say greater than, or they just say not equal to -1, they can determine if the string is contained within if the substring is contained within the string. Well, this is actually not the right way to write this code. The right way to do it is to use a function called test, and it's more concise. So the way you would actually want to do this is you would write a regular expression, and then you'd run the JavaScript method test against the string. In this case, it's window.location.href. And then the string that we, or the regular expression or string that we care about, we would just pass that in like so. And this will always evaluate to a Boolean. So again, if we wanted to write code that said, console.log, UTM medium is found. The way that you properly write that is you do a regex, and then against the test string, And that's how you do that. And if you wanted to say not found, so say UTM medium is not found, you could just invert the regular expression by prefacing it with a exclamation point or bang. So this evaluated to false because we do in fact have UTM medium. And that's the better way to check for substrings within strings. Okay, so I want to show you one more way you can create a regular expression in JavaScript, which is to use the regex object. So we could do var pattern equals new regex. And then the first argument is the regular expression itself. So we could do any letter, one or more. And then the second argument is the flags. So we could do GI for global, case insensitive. And then we can just test it using test. And then we'll throw a test string in here. And this should evaluate to true. And we could also see what the regex is by just logging it like that. The only time I use the object is when I want to pass a variable into the regular expression. So for instance, if I did var user equals Tim, say I wanted to create a regular expression out of the variable Tim, the only way to do that I know is to do use that regex object. So you could do but say we wanted to like add something else to it, we could do right, so that's the only way to create a regex dynamically, is to use the regex object. But short of that, if I'm writing a regex, I just write it inline like this, and then I can test it against the string just like that. Okay, so I want to show you another example here. So we have a CodePen script up here that is just showing a very generic input login form. And where you might want to use regex is to validate on the client side whether the password is valid or not. So if the user types in something that we know doesn't follow our password requirements, then we don't even have to send it to the server. We can just notify the user that the password is invalid. So that's what this code is doing right here. Every 2 seconds it's running, it's taking the password field, and then if it's greater than 4 characters, we will run an evaluation sequence here. So I'm just going to modify this code to check that we have digits, that the length is greater than 8, and that we have an uppercase letter. And if those are all satisfied, then we allow the user to proceed. If they're not, then we show an error message. Okay, so what I did with this code is I said don't evaluate the password unless it's greater than 4 characters, just so we're not annoying the user before they've typed anything. But once they have typed greater than 4 characters, we check that the password is at least 8 characters, 8 or more characters. We check that there's a capital character, 1 or more, and then there's a digit, 1 or more. And if any of those are not true, that's why I put the bang in front of it. If any of them are not true, separated by the or, then we throw a validation error. So let's just do username is refactored, and then password will be my name is Tim. And you can see we didn't meet the digit requirement. We didn't meet the capital requirement. So let's see if we can't rectify that. So we'll add a capital letter in there. So we're still out of compliance because we don't have a digit, but if I throw a digit in there, then the error message goes away and we're able to proceed and log it. So you can see how regular expressions can be used for client-side form field validation. Okay, so say we want to do some web scraping. So I have an app script here that is going to make a URL fetch to reddit.com. And say we want to get the titles of every post on this page. Well, first we got to see what does that actually look like in the HTML of the page. So first we'll start off by just logging the response. So basically what this code does is it just makes a request for reddit.com and it logs the initial HTML source. And then from that HTML source, using regular expressions, we should be able to extract what we want. So let's first just take a look at how this is constructed. So I'm going to refresh reddit.com, and then we'll just look for one of the posts title, and then we should be able to determine what's what. So there's a post called "Tell Me Your Favorite Video Game." So I'm just going to look in the HTML. Oh, that's the wrong one. Tell me your... All right, so it actually looks like there's kind of like a data layer here that we might be able to use. So let's take a look at this. All right, here we go. So there's a data layer that we can match on. So we can write a regular expression to find that. So we're going to come over here and we're going to say, take that response HTML and let's evaluate a regex against it. So a couple things here is, I don't know if there's always going to be a white space, so let's do \s*, and then what we actually want is what's contained between the two double quotes. So we're going to use a negated character class to say match on anything that is not a double quote. And let's go ahead and see what this returns. Okay, so it looks like actually we did get all the titles. So let's just write a little bit of code to make these a little bit prettier. So what we're going to do is let's iterate over some of this stuff. So this is an array. And we're going to do dot for each. And we have two parts here. I forget what they're called. So I'm going to do A and B. And then we'll add a new line in there, and hopefully that will make it a little bit prettier. But actually, we don't want console.log, we want logger.log because we're using an app script. Let's see if this helps us read the data better. So it does. So this looks pretty good. So these are the titles of the posts, but we don't really care about this part here. So what we can do is we can actually remove that if we want. So let's go ahead and do the following. So I think A is the actual search term. Let me confirm that. Yeah. So we can use regular expression actually again to remove some of the text that we don't care about. So we're going to look for a regular expression that says title. So we're looking for a regular expression to match on that text that we don't care about, and then we're replacing it with nothing. So I think this is going to give us exactly what we're looking for. Yep. So you can see, so not everything was a title, so it got some other stuff in there. But tell me your favorite video game and I will guess your age, just an idiot, interested in getting a new perspective. Okay, and we're getting some of those titles of those different posts. So it's very easy to extract data based on a pattern from even complex or unstructured test strings, such as just the HTML of a page. So you can see this is pretty powerful here. And I just want to show you that regular expressions are used very extensively. So I'm just going to youtube.com and I'm going to go over to sources. I'm going to do a deep search using Command Option F. And we're just going to look for the regex object. So I'm going to search for regex, and we get a bunch of JavaScript files, all that reference regex. So you can see it's used by all these different files because it's helpful. So this isn't just some one-off function. This is a core part of programming that you should really add to your repertoire. All right, so I want to give you a quick glimpse into how regex might work on Python. So there's a package called re, and you run this re.compile function to create a regex, and then you can use that object to use that object's methods. There's search, find all, match, think find all is the most useful, and it will return the results of that regex against the test string. So we're looking for any number of characters, lowercase, and you can see we return those proper characters, and then maybe we throw in uppercase as well, and that should slightly modify the output. So now we're capturing every word, and really it's pretty much, you know, very similar to how we did with JavaScript. You can take some search string and find some needle within that haystack. So really accessible. I hope this video was helpful, and as always, if you want to stay apprised of the latest emerging tech around AI, machine learning, IoT, and general web development, go ahead and click that subscribe button. Thank you.